There are different styles of chemical equations. The one we've been looking at so far is called a molecular equation, and that's going to show the neutral formulas for all of the compounds that are involved in the reaction. And it is very good in some ways. The complete ionic equation is going to show any of the aqueous ionic compounds as ions. And this is really more accurate because those ionic compounds that are dissolved in water, their ions are separated from each other. And so in the equation we also separate the ions from each other. But we do that only for aqueous ionic compounds. Do not separate solids, liquids, or gaseous compounds into ions. So we do a complete ionic equation, and when we look at it, we find that there are some ions that don't get changed. There's maybe a chloride ion present as a reactant and a chloride ion present as a product. Nothing happened to it. We call those spectator ions because they're just watching the reaction. It's like when you go to a boxing match and you watch two guys beat each other up in the middle of the ring. And you come out and you look the same as you did when you came in. You don't have a bloody nose and a black eye, right? You were a spectator. You were just watching the action. So those are the spectator ions. So then we have a net ionic equation where we leave the spectators out because they didn't really participate anyway. And the net ionic equation just shows what's actually being changed, what's actually involved in the chemical reaction. The other ions are just along for the ride. And net ionic is a little bit like your net paycheck, right? You've got your gross pay, which is always bigger, and then what they actually let you take home is smaller, right? Because they take out the taxes and all this other junk. So your net pay is after they take all the stuff out. So the net ionic equation is after we take the spectator ions out. So let's do an example. Here we're handed a balanced chemical equation. So this is the molecular equation. This is showing formulas for all the neutral compounds that are involved here. And they're saying write a complete ionic equation and a net ionic equation for this reaction. So what we're going to do is we're going to look at each of these compounds, and if it's aqueous, we're going to separate it into its ions. This one's aqueous. This one's aqueous. That means that it's dissolved in water, the ions are separated, so we're going to write it that way. Water, though, is listed as a liquid, so we're going to leave him alone. And then we've got another aqueous compound over here. I'm going to leave the state symbols out because it just gets very long when we separate everything out. So HBr contains hydrogen ions and bromide ions. The equation, though, tells us there are two HBr's. So how many H pluses are we going to have? 2. And how many Br minuses? 2. So 2 HBr separated into 2 H plus and 2 Br minus. And then we've got calcium hydroxide. Well, the calcium ion there is Ca2+. OH2 tells us there are 2 hydroxide ions. So I'm going to write 2 hydroxide ions. All of these are ions. You have to include their charges. Because calcium ion, Ca2+, is very different from calcium metal, which is just Ca. So if it's an ion by itself, you have to write the charges. So those are the reactants. Then for our products, water's a liquid, so we're just going to copy that one down. We're not going to do anything to it. Leave them alone. And then calcium bromide is aqueous, and so that's calcium ion and 2 bromide ions. And ideally you would put all the state symbols in, but there's just not enough room. Any questions? That is the total ionic or complete ionic equation, showing all the ions that are present. Which of those ions are just watching and not actually participating? There's two of them. They're the same on each side. The calcium and the bromide. Because here we have Ca2 plus and Ca2 plus. Same on each side. The hydrogen here, H plus, we don't see an H plus over here. Something happened to him. So what we're going to do is we're going to identify the things that are the same on both sides, and we're just going to cross them off. So there's the same number of calcium 2 plus ions on each side, and there's the same number of bromide ions on each side. They didn't really participate in the reaction. They were just watching. So then for the net ionic equation, we're just going to copy down what's left. So we get 2H plus 2OH minus forming 2H2O. Now that's balanced, right? Could we make it simpler? What if we divided all the coefficients by 2? Yeah, we could do that, because they're all 2's. So simplest is H plus OH minus, forming H2O. And that's our net ionic equation. Because what happened here, hydrogen came in with bromide. But if hydrogen had come in with chloride or iodide, the net reaction would have been the same. Hydrogen ion would have hooked up with hydroxide. Who he came with didn't matter at all, as it turns out. And the hydroxide came in with calcium, but if she had come with sodium, she still would have hooked up with the hydrogen ion to form water. Her date really didn't matter. And so in a lot of these reactions, there are two ions, one cation and one anion, that aren't really participating. It's just that you have to bring a friend, right? You have to be part of a couple to come to this party. And so here I brought this person, but leave them, and oh, there's the person I was really interested in. It's crazy, huh? Yeah. You just play with that. It used to be wife swapping, but I cleaned it up a little bit for YouTube.